So this is the coupling system. The coupling system including several parts. The coupling relationship between the fluid and structure, because the train, we can see the train like a structure when running on the railway line. So there will be coupling relationship between the fluid and the train, and then the the power, the electricity current is from the catenary by the pantograph to the train to supply the power electricity for the train. So there we should consider the relationship between the uh, pantograph and the catenary, and then we should also consider the coupling relationship of the electrometrical equipment, the traction power supply station, and another important part is the relationship between the rear and the rail. So there are many coupling relationships. For example, the coupling relationship between trains. For in this picture, you can see this carriage or this train and this train, or when the train running against each other, the train will meeting each other. So the the coupling relationship between the trains we should consider, and the coupling relationship of pantograph and catenary, the coupling relationship of via rail, and the coupling relationship of route, coupling relationship of fluid and structure. For example, the window and the train. This is the coupling relationship of fluid and structure, and the coupling relationship of environment. We consider the temperature variation, consider the wind, consider the earthquake, and so on. The service simulation of high-speed train engineering structural coupling large-scale system. First, we can consider the dynamic response of the high-speed train. Then, including the dynamic response of the catenary and the dynamic response of line, bridge, and tunnel, and subgrade, and so on, and the dynamic response of airflow field, and the response of the traction power supply system. So for these systems, there are some connections, the coupling connections or coupling relationship of fluid structure, the coupling relationship of pantograph catenary, and the coupling relationship of electromechanical equipment, and the coupling relationship of via rail. Then we can get the train behavior and coupling effects and the service process or service performance of the system. So the dynamic model framework, this figure shows us the dynamic model framework of high-speed train engineering structure system. There are several big parts. One part is the airflow. For the airflow, we should consider the aerodynamic force. So the aerodynamic force between the train and the air, and the interaction between the pantography and the catenary. So because the current is from the catenary to the pantography and to the train, so we should consider this interaction. And the force between carriages. A train generally including several carriages, so the force between carriages we should consider, and also the force between trains when the train running against each other and meeting each other. Then the force or the interaction between the train and the substructure. For example, the interaction between the via and the rail. So the force will be transferred from the via to the rail, and then the force will be transferred from the rail to the ballastless track and to the embankment. So there are many substructure methods, including the airflow, power station, catenary, pantograph, train, traction drive, rail, and track structure, foundation. For all this substructure, we have the physical and mechanical equations to describe their relationships. For example, the traction power supply system model, we can use this equation, and for the catenary, we can use this equation, and for the equation of airflow motion, we can use this equation, and then for the high-speed train tenor model, for example, the force between the wheel and the rail and the normal pressure and the creep force, we can use some equations to describe. So for this substructure system, or we can use many physical and mechanical equations to describe them and do the numerical simulations. This picture shows us the train information platform. You can see including the train information configuration panel and the train model library. When the train running on the various lines, we can see this information, the parameters of the first train and the initial position, attitude, and the train parameters, and some total numbers of the formation. And this big picture shows us the service simulation process for the theoretical modeling. This part is the input system, including we can consider the irregularity of the track structure or lines, various lines, and we can consider the airflow, we can consider the environment, for example, the temperature variation, the water influence, and the freeze-thaw cycle, and the snow, and we can consider the earthquake influence. This part is system modeling, including the pantograph, catenary system, power supply system, locomotive, transmission system, track system, and the basic structure. Then we can do service simulation calculations. Of course, we should consider the material failure model and structural failure model. Then and consider the time varying parameter calculation model to do the numerical simulation. Then to evaluate the service dynamic response of the system, including the stability, stationarity, safety, and reliability of the system, to evaluate the service response